Administer and migrate virtual machines and vApps. All right, so I told you that this was sort of part two of these two nuggets on working with virtual machines and vApps. And in a way, this second part is, when you look at the exam objectives, I've kind of consolidated two objectives into one, the administer virtual machines part with the migrate virtual machines part, because I don't know, in a way, they're almost kind of the same thing. When you're migrating VMs, that's part of the administration task. So I want to spend some time really helping you understand what those administration, just the activities are, and also what the different options are and how you can set resource controls and things like that. In this nugget, there are a wide array of different activities that we've really got to touch on. And so I'm just going to kind of list them here so that we can be prepared for what we're going to talk about. I want to spend a minute here talking about the virtual machine files, so that when you create a VM, what sorts of files get created and where are they at. And then also when we get down into the migration discussion, it's important to understand what the virtual machine requirements are for vMotion and also for storage vMotion, which is the vMotion, but instead of actually moving the, I guess I'll call it the brains of the machine, I'm moving the body of the machine from one data store to another. When we get into the interactive portion, what I want to do is spend some time talking about those virtual machine options that we sort of glossed over in that last nugget, and then also the resource controls that I told you I was punting on until this nugget. We're going to talk a little bit about virtual disks, how you can hot extend one, how you can convert its provisioning format, how you can work with storage policies just a little bit more. I know we've touched on storage policies already just a bit. And then we're going to work in those two topics associated with migrations and specifically the vMotion storage vMotion activities. What's interesting is that it's funny because vMotion, particularly when it first came out, was a really, really exciting activity, and people were really excited about seeing vMotion, but in a way there's really not that much to see. Most of the real excitement occurs under the covers and not necessarily in locations where there's anything to look at. So here we are back on our vSphere client, and I have taken the liberty of actually installing a copy of Windows Server 2008 onto VM1. That's the VM that we began the installation with in that last nugget. Now, I did this because I needed to complete this installation, the OS installation, so that I could go about actually installing the VMware tools. Again, I did that by right-clicking once the installation was complete, choosing Guest, and then Install Upgrade VMware Tools. You'll see here that the VMware tools are running and that they are current. This is important because those VMware tools are a part of the entire process that's involved with completing a vMotion between two different hosts. Now, before we get into that, I think what I'd like to do first is really give you an idea of the storage that these virtual machines may be using. Now remember, we were using VM Data Store 1 as the storage for this virtual machine that we created last time. If I right-click VM Data Store 1 and choose to browse the data store, you'll see that I have a couple of different files in here. One of which is the folder with the same name as the virtual machine that we created. And inside this folder are a whole series of different kinds of files that have been created in support of this virtual machine. Now, you should become intimately familiar with what these file extensions are. Some of them are more important, others less so. The ones that are the most important for you to understand are going to be pretty much in order. The VMDK file, which is the virtual disk file. This is generally the largest file on the system because indeed it's the entirety of that virtual disk. The VMX file is the virtual machine configuration file. Now what's interesting about this VMX file is that this VMX file is actually stored, the configuration for that virtual machine is stored in a text format. So I can actually take that VMX file and open it up inside of a text editor if I want and see information about how the configuration of this virtual machine should look. I'm going to do that now. I'm going to open up Notepad here for this VMX file, and you'll see here, let me turn on word wrap. You'll see here that there's a number of different settings that are associated with this file. Now these settings are kind of garbled up here, so Notepad's just a little challenging to use to actually see what's in the file. So let's move over here to WordPad, and I'll show you an interesting difference between the two. Take a look here. I'm going to do start star so I can open up the file. There's that VMX file. And now inside of WordPad, I actually see these where each setting is highlighted one per line. every single configuration that you make to this virtual machine is going to be stored in this VMX file. So you'll see here, I can see, okay, here's the config version 8. That's VM version 8. This is PCI bridge 0, 5, 7. Let's see what else is down here. The IDE drive, the SCSI drive, the floppy drive, some Ethernet information here. You'll see these same VMX files associated with the VMs that you create inside of VMware Workstation. And the idea is that, this VMX file is intended to be portable and can or may not necessarily be associated with or move around with the virtual machine. Now, this might be a little confusing to you. Okay, I've told you that there's a disk file, and then I've told you that there's a configuration file associated with that disk file. You can actually take this VMDK file and directly copy it to some other location, some other vCenter server somewhere, and then create a new configuration file that is associated with this VMDK file. You don't actually have to send the VMX file with it, but you can. If you want the virtual machine to maintain the configuration that you've given it, well, then you'll send both files. If you're just interested in what the contents of the disk are, well, then you'll just send the VMDK file. This is the logical metaphor here would be somebody needs a copy of or an instance that I have here on this physical computer. I can either send them the hard drive, and they can put that hard drive in a similar feeling, similar configured computer. Or I can send them the entire computer. In certain circumstances, it may be easier to send them the entire computer. Other times, it may be easier just to send them the hard drive. So these two files are really the most important ones that you need to be aware of because they're really the guts of your virtual machine. The VMDK file, I like to think of it as the VMDK file might be the body of the VM, with the VMX file being the brains of the VM. There are a number of other files here as well. Obviously, the log file is where all of the key log information is stored about that virtual machine. There is this vSwap file here that usually is created at the time the virtual machine is powered on. If I power this virtual machine off, this file gets zeroed out. The vSwap file is there as essentially a swap location for the virtual machine's uses, and the size of this swap is generally about equal to the amount of associated RAM that you've targeted or you had applied to that VM. You'll see there are in fact two vSwap files here on this VM. The NVRAM file here is more or less just the contents of the virtual machine's BIOS. There are also a VMSD and a VMXF file that you see here. Now the VMSD file, which is currently zeroed out, is the contents of any snapshots that have been created for this virtual machine. Now I haven't created any, so you'll see that the file is currently with 0 bytes. There's also a VMXF file here, that's the one up here at the top, and that's used for some supplemental information for when a virtual machine is part of a team or vApp or things like that. So you will see these files in there. If you're taking the exam, you got to know what these file extensions are, but these are the ones that you're going to find when you're playing around with your virtual machines. So it's important to know what these files are, but actually working with the VMs is also important as well. You're going to be spending more time actually working with the VM than you are playing around with its individual files. I already showed you this screen. We did that back in the last nugget here, where we took a look at how we can adjust some of the configurations for a virtual machine. Now, one thing that's different, however, is that you'll see most of the settings now are grayed out because I can't actually manipulate many of these settings while the virtual machine is powered on. I can, however, add in certain types of devices while that VM is powered on, such as Ethernet adapters, hard disks, SCSI devices, USB controllers. So with the machine powered on, certain things can be done, certain things cannot be done. Over here in the Options tab, which we didn't look at, you'll see that I cannot reselect a guest operating system with when the virtual machine is powered on. If I have, however, conveniently, which I do have, a powered off virtual machine, I can show you some more about those settings because they're going to be exposed for me. So back under here into the Options tab, I can change the VM name if I want or reassign its guest operating system. Always make sure that this links with exactly the OS that is actually inside the virtual machine, or otherwise you're going to end up with some performance disoptimizations. Some options here for vApps. Do I want to enable those vApp options or not? I can select this here. Within the VMware tools, I have a number of options for what I want the different VCR buttons to do when I'm interacting with this virtual machine. Now, by default, you're probably not going to change these that often, but do you want to shut it down versus power it off? Do you want to suspend it or anything else, really? Do you want to restart it or actually reset the VM? Do I want to run the scripts associated with that? Do I want to upgrade the tools during the next time I power cycle a machine? So all of these are items that you would choose to interact with the VMware tools and what it will do. When the guest OS is placed in standby, what do you want to do also? Suspend the VM or put the guest OS in standby and leave the virtual machine powered on? Again, more options here. Down here under Advanced are a number of options that you're probably not going to be adjusting that often. Things like disabling acceleration or turning off logging because it's turned on by default. Some debugging and statistics. If you turn on these debugging and statistics information, you're probably going to reduce the performance of the VM as it goes through trying to monitor all the things going on. There are some additional configuration parameters that if you are working with, for example, VMware's technical support, you may adjust these or make changes if you need to change the permissions, or excuse me, the performance settings for your VM. But those would be specifically told to you for things to do. CPU ID masks, generally you don't touch this at all because for the most part you're going to want to expose both the NX and XD flags. One is from Intel, one is from AMD. That enables the vMotion compatibility, it's part of the vMotion compatibility with different machines. If you hide that, you might increase the compatibility, but at the cost of certain performance features. So again, you just really don't adjust these. If you really want to get advanced, you can actually go into the virtual machines and interactively determine which of the processor functions that you're actually going to enable or mask or change for a virtual machine. But this is way, way, way advanced level stuff, most of which will invalidate this virtual machine from being supported by VMware. So again, probably don't make many changes here with the CPU identification mask. Same thing here with memory and CPU hot plug. Right now, memory hot add and CPU hot plug are disabled, but you might want to turn these on if you have the need to turn them on. Most of us, except in a very critical, heavily mission critical environments, are really not going to make use of hot add or hot CPU. A lot of us can afford the couple minutes of downtime to shut the VM down, add another CPU, and then power it back on gracefully. We have some boot options here. ESX5 now includes the EFI boot firmware. I can set a power on boot delay so that I am sure that a virtual machine waits a little bit before it powers on. I can force directly the virtual machine to go into its BIOS. This can be important, really useful sometimes when you have need to go into the CMOS and adjust settings in the CMOS, because that CMOS goes really, really fast. By selecting this checkbox, the next time the virtual machine boots, you'll force yourself into that BIOS setup screen to make adjustments to it. Also, when the virtual machine fails to find the boot device, go ahead and retry. If you're using NPIV, if you want to make some changes here to your fiber channel configuration, CPU and MMU virtualization, again, most of the time you're going to set this to automatic because there's not really much that you can gain and plenty that you can lose with these types of settings. And then lastly, also the swap file location. So these are the options that are available for every virtual machine that are out there. I also, in the last nugget, talked a little bit about the resources and how you can configure different resource constraints on virtual machines. A lot of this doesn't make too much sense until we start getting into the notion of hosts and clusters, because it's clusters and resource groups that are really where the boundaries of these resource allocations are going to be set. That said, however, it's good to understand where resource constraints are set at a virtual machine level, because the understanding here will help you flow into the understanding at the resource group level, the cluster level. See here I have a CPU, memory, and disk as the three different types of resources that I can set allocations to, the most common of which are CPU and memory. They've been around the longest. I can, with a CPU, set a reservation or a limit on that CPU utilization. Now what this does is it says, all right, I want you to set a hard limit on the most amount of megahertz of processing that this CPU can use. Okay, the workload, the whatever application you've installed into that virtual machine may need more, but you're going to hard set that limit here at this location. Or you may conversely want to set a minimum threshold that is always guaranteed for use by that virtual machine. No matter what the behaviors are of the other VMs on this host, you know that you're going to get that minimum reservation for CPU. Finally, you may just want to, instead of actually defining specific reservations or limits, you may just want to set a normal, low, or high number of shares to this virtual machine's CPU. Now, these are nice because if I have certain virtual machines that I will have more attention, or I want them to receive more attention from resources, I just set them to high, and then they've got what they need. And the ones that I'm less careful about, I can set to low, and that makes it very easy. I can also customize the number here by choosing custom and choosing a number. Now, the absolute values of these numbers, this is 500, the next one would say, I don't know, 1,000. The absolute values of these numbers are not important whatsoever. It's the relative values of these shares. If one machine has 1,000 shares and the other machine has 2,000 shares, well, the second machine is going to get more resources, equivalent to the difference between 1,000 and 2,000. All of this, what you've seen so far, is just for limiting the CPU, or setting reservations for the CPU. I can at the same time do the same thing for memory as well. Okay, do I want to reserve guest memory? Do I want to lock it out? Do I want to set a reservation or a limit or some shares on guest memory? These are things that you might do in order to protect your other virtual machines that are on that same host from a specific VM that's using too much of the stuff that you have available. You know, your classic SQL Server example, where the SQL Server tries to eat up as much RAM as you can give it. Well, you might set memory reservations on other VMs. Now, it's generally a good idea to not use these unless it's an absolute requirement. If you have an application that you can throttle its CPU or its memory use in the application itself, it's always a better idea to do so within the application than to try to set these hard reservations. The virtual machine does not necessarily have exposure to the limits that you're placing on it. And so if you can set this inside the virtual machine, you're generally going to get a better response than if you do so outside of the virtual machine. Now, disk shares are relatively useful here because in modern times, I guess in the last couple of years, many virtual environments have realized that the disk is becoming one of the biggest bottlenecks to performance. Now, disk shares are important because with disk shares you can actually limit the maximum number of IOPS, for example, or the shares that are associated with those IOPS, the input-output operations per second, for the disks that are attributed to this virtual machine. So think about this. I've got a number of VMs that are trying to touch this central shared storage. And when they're all trying to do their activities, they're all trying to tell that storage, I need stuff from over here, I need stuff from over here, I need stuff from over here. And the storage does the very best job that it can in retrieving that data and updating that data based off of what the VM requires. When you end up in a situation of contention where the virtual machine requests are greater than what the storage can provide, well, you're going to lose performance. And so what resource allocations here with the disks do, just like with CPU and memory, is give you a mechanism to limit the disk requests for very noisy virtual machines to protect the experience for everybody else. Down here in an advanced CPU are some other of these advanced settings that you're generally not going to set that often because these would identify, for example, which physical processors you might use for this VM or whether or not you wanted to do core sharing for hyper-threaded CPU or hyper-threaded cores that you have. Both of these, again, you really don't touch that often. So these are the virtual machine options and resource controls that can be placed on a virtual machine. Most of these, as I said, you're not going to mess with. There's just not that much that you need to do with these virtual machines. Now, there are some settings that you might want to do, and many of these have to do with, for example, the virtual disks. You can actually hot extend virtual disks here inside of vSphere version 5. Here's my VM. This is VM number 1. It is operating. It has Windows Server 2008 installed onto it. If I go back here into Edit Settings, and I take a look at its hard drive here, there we go, you'll notice that I have a provision size of about 41 gigs right now. Now, this virtual machine is operating. It's up and running. It's doing whatever it needs to do at this point. And perhaps, I've walked into the office today and I've got alert that VM1 is just about to run out of disk space. What do I do? In the physical world, well, this can be a problem because I've got to go and add more hard disks and just do all that really awful management, the physical management activities that are required in the physical world. In the virtual world, well, things get a lot easier because hot extending a virtual disk requires nothing more than, well, just upping its provision size and clicking OK. When I do that, you'll notice that I'm going through a reconfigure virtual machine task here to complete that hot extension of the VM's virtual disk. If I now go back to Edit Settings and I take a look at the hard disk again, you'll see that my provision size for that disk is now 45 gigabytes instead of 41. So this really significantly eases the process of adding additional space to the volume that's been exposed to that virtual machine. You know, depending on your operating system, you may have to go into that operating system and then extend the volume as well, that usual two-step process that's involved with doing that. But this first step, actually giving it more space, if you have the space, well, that's very simple for you to do. Now, when we created this virtual machine, we created this virtual machine as a thin provision virtual machine. And I think I mentioned earlier that thin provision virtual machines, they're great for storage space because they don't consume anything until they actually need to consume it. But thin provision disks sometimes have a little bit of a performance hit because of that thin provisioning process whenever I'm adding more data. I'm extending the volume size beyond what has been existingly provisioned for that VM. In these cases, I may want to convert my thin to thick. Or conversely, I may want to convert my thick to thin. Now, how do I go about doing that? There are actually a couple of different ways to accomplish the task. One such way uses the command line tool vmkfstools. Doing so with vmkfstools with a powered off VM, you can run a single command from the console of the ESX host and actually have it go about converting the thick to thin or the thin to thick. Now that's all at the command line. I'm not really terribly interested in showing you all the command line pieces today because I think in practice you will probably be making more use of the user interface tools. So be aware, especially if you're planning on taking the exam, that the vmkfstools command is one that you would run from the local console or from SSH. However, inside of this interface, right here inside of the vCenter client, I want to actually figure out how I might convert this from a thin to perhaps a thick provision disk. One way that I can do so is by doing storage vMotion. Now, that is the migration task here, one of the things that we wanted to talk about here in this nugget. If I right-click on a VM and choose Migrate, I have a number of different options that are available for me for where I want to change things. Okay, maybe I want to change the host, a classic vMotion, right? I want to move this virtual machine from one place to the other. Perhaps I want to change the data store. Okay, so I want to leave the virtual machine running on the same host, but I just want to move its body underneath to a different data store somewhere else. I can also do both at the same time if I want. However, doing both at the same time requires, as you can see here, the virtual machine to be powered off. I'm actually going to do these kind of backwards because I want to show you the changing of the data store first, or the svMotion, before I actually show you the vMotion. And I do this because if I change the data store here, you'll see one very important selection box here up here that says select a virtual disk format. So remember, what is a storage vMotion? What is an svMotion? The brains of the VM, the processing of that VM, does not leave the host where it is currently operating. However, the body, the disk of the VM, changes data stores from one location to another. Now, when I go about doing that process, I have the ability to change the virtual disk format. So here's my svMotion configuration screen here. Okay, and currently this virtual machine is sitting wherever it happens to be sitting. And perhaps I want to migrate it to the NFS mount so that I want to put it over on NFS. And I want to do so just simply so that I can actually move it from a thin provision disk to a thick provision lazy zeroed disk. All I need to do at this point is actually, like I said, choose the virtual disk format, choose the location where I want it to go, click the next button, and then finally finish, and this entire process will move that virtual machine's VMDK file from one location to the other, and then change the disk format on my behalf. This is excellent. The one thing I will tell you, however, is that an svMotion is a relatively long process, actually going through completing the svMotion. While it does so with the virtual machine staying powered on, well, moving the brains of a virtual machine, the processing of a virtual machine, really only requires moving its memory contents. But in order to move its body, that's the entirety of the whole virtual disk, which can be very large. in this case 45 gigabytes in size. So doing an SV motion is going to require a fairly extensive period of time. It could take a very long time, many minutes, to complete an SV motion. You'll want to do this carefully. And you'll also, especially as we get into storage DRS a little bit later, you'll want to plan these things out before you actually go about doing them too terribly often. Now you do have to be conscious too of the requirements that are associated with being able to do a storage vMotion. Obviously your licenses have to support the running of storage vMotion. If you don't have the right licenses purchased, you just won't be able to do storage vMotion. In the last nugget I talked about the use of persistent mode. Your virtual machine disks must be in persistent mode or they must be raw device mappings in order to support SV motion. If you're in the process of running VMware Tools installation also, you're not going to be able to run SV motion. And this sort of goes without saying, but whatever host the virtual machine is running on has to be able to access both the source and target data stores at the same time. So a couple of fairly minor but very important requirements that you'll have to be aware of whenever you are considering doing a storage vMotion. Really, the kind of the fun part, I think the part that really interests more people is the whole vMotion process. You know, we've been told for a very long time that vMotion is one of these really cool things that allows, for example, this running VM, VM1, to move from ESX2 to ESX1. So let's shift away from storage vMotion and shift towards just regular vMotion because it's just fun. I'll click Migrate again. All right, and this time instead of changing the data store, I'm going to change the host to move this virtual machine to another host. Now you'll notice that I have a selection of destinations that I can choose from. Here's ESX1. And before I actually am allowed to go through the process, I need to make sure that the compatibility validation does succeed. Now, vMotion itself has a set of requirements that you have to be able to fulfill before a vMotion can actually occur. Remember, a vMotion is a virtual machine that's running, and the virtual machine does not power off. And so I need to have certain similarities between the source and the target host for this entire process to work. I have to have two servers, first of all. They have to have similar processors, same manufacturer. So Intel to Intel, AMD to AMD. They also need to be relatively close in terms of the family and the stepping. Now you can actually go to VMware's site and get a list of which processor types have the ability to vMotion with other processor types. Now I won't bring it up, but check out VMware's website for the processor compatibility matrix to ensure that all of your hosts have the ability to vMotion with each other. I'll put in a little WAG here for a little bit later when we talk about clusters. There's another tool called the Enhanced vMotion Compatibility which makes this process a little bit easier. Have to have shared storage also. The virtual machine has to be able to be talked to from the different hosts that we're going to move it from. This is not a storage vMotion, this is a regular vMotion. And I also have to have vMotion available for the license type I have and have vMotion available. If you recall, when we were actually configuring the hosts here back a number of nuggets ago, we were taking a look here at networking, and when we created that VM kernel port for the management network, we went back here into properties and took a look at how we were configuring that VM kernel port. And that VM kernel port did indeed support vMotion. So another requirement here for vMotion is to make sure that you actually have vMotion enabled for a management port somewhere across all of the hosts that are going to participate in vMotion. If you miss this, you're going to fail that validation. So have that. And then come back here to the virtual machine, go back to Migrate. We're going to change the host, set it up to ESX1. Well, let's see what happens. I have the ability to select whether this is going to be a high priority or a standard priority vMotion. And as you can imagine, the high priority ones go first. I'll choose Next here and Finish so that we can go about taking a look at how this works. You'll see here that the virtual machine is migrating. Right? It is still operating here. I can still take a look at its console and it's doing the things that it's allowed to. Once it completes the migration here, you'll see that the migration is completed. I see VM1 is currently executing here on ESX1, and there's that console again. It didn't show up fast enough for me to prove it to you. But this virtual machine has not powered off. if I ran a ping packet against it, I might lose a single ping packet. And so the clients that are connecting into this VM are really not going to see any period of outage for that VM as it moves from one place to the other. I'm now executing on ESX1. So this is fairly exciting in terms of, well, I could move these VMs around. This gets much more exciting, however, when I start thinking about the mathematical models and the monitoring that I will put over the top to ensure that the VMs balance themselves appropriately and have failover capabilities. And all of that we'll talk about when we start talking about clusters. Now there is one more setting here that we do want to take a quick look at here for these virtual machines, and that setting has to do back in here with the hard disks. Now remember when we were looking at these hard disks, and we were taking a look at the different types of user-defined profiles that we can set for the potential disk capacities that are out there. These are those VM storage profiles that are available. Now, I can assign user-defined storage profiles, and I believe I already did once, to this whole system here. I can also have, based off the integrations that I have with the right storage, have my storage identify what its potential characteristics are. Once I have those baked into this system, then I can assign them to each virtual machine so that I know that high-priority virtual machines get access to high-performing disk stuff. Now, one of the ways that I do that is I take a look here at, under Inventory, and I want to go down here under Management and VM Storage Profiles. The very first thing you'll want to do if you have not turned it on is to click to enable VM Storage Profiles here for the different hosts in your cluster. Completing that process should take just a minute or two. I've already done it here. It's really nothing exciting to look at. Once you've done that, then the next step is to actually create a VM storage profile. So what are these things? My VM storage profile. Right? And I can name a description here. The profile identifies what different possible capabilities are available for that profile. Now, I've already created one capability. That was the awesome capability that I defined earlier. Now, you won't probably call yours awesome, but what you will do is identify different capabilities that different types of storage may have. It's a SAS storage, it's high-speed storage, it's redundant storage, it's replicated storage, all these different things that are possible that you can then aggregate together to create a VM storage profile. So I've just created one here. Here's the VM storage profile that I have. Here's just some summary information about it. You'll notice that I can then, once I've created the profile, identify which virtual machines I want to tag with that profile. Okay, do I want to check to see if they're compliant with that? Okay, do I want to ensure that those virtual machines have the capabilities that I want them to have? Now, the capabilities up here can be defined both in the user-defined standpoint. Here's the awesome one that we created before. I can add an additional ones here by clicking Add. Or, as I said before, the storage itself can assert what capabilities it may have. The ultimate goal with these profiles is for you to ultimately tag the virtual machines that you're creating with the profiles that you want them to support. So here I am back with the VM again. Here's VM1, it's running on ESX1. Let me go back here and choose VM Storage Profile. If I choose Manage Profiles here, you'll see that I can now select the storage profile that I want and propagate that to the disks that are associated with this VM. In the end, what this allows me to do is to ensure that I'm meeting the type, or I'm compliant with the types of features that I need for this virtual machine to do whatever it needs to do. Now, all of this takes us back to, well, how do we administer and migrate our virtual machines in vApps? Doing all of these things with vApps, kind of the same thing as working with virtual machines. You can migrate vApps just like you would a virtual machine, and that's really why you would create a vApp. In this nugget, we talked about what are the files that are associated with virtual machines, and then also some of the requirements for vMotion, storage vMotion. And then we spent a really good amount of time talking about really the administration tasks associated with virtual machines, and then also the migration tasks associated with virtual machines. You now are you're fully aware of the things that you need to do to manage those virtual machines and be successful with them. At this point, now we're going to start working with collections of virtual machines and then how we manage multiple virtual machines on top of multiple hosts. I hope this has been informative for you, and I'd like to thank you for viewing.